and needed another opinion or extra information to assist you with your diagnostic process? Have you fully explored what onboard diagnostics can provide? When breaking down the SAE and ISO standards that form the framework for OBD2, or the equivalent European standard, we can identify the key elements that are important to understand when approaching diagnostics. We will be exploring several elements in more detail and looking at how this information is accessed and displayed using a scan tool on an OBD2 or EOBD compliant vehicle. Depending on the scan tool used, we'll determine how this OBD information is displayed, but in essence, the generic OBD program will cover multiple software modes. The generic OBD program is a dedicated program when compared to the vehicle-specific software selection. The key elements that we will be focusing on include the display and structure of fault codes, fault recording via freeze-frame data, monitors and criteria for components and system faults, vehicle drive cycle framework, driver fault notification, vehicle emission levels, components and system information terminology, and access to service information and calibrations. Let's take a closer look at these particular key elements. Fault code structure is clearly defined under OBD2, which is in accordance with the SAE standards. There is scope within these standards for manufacturers to develop their own specific codes, although these must follow the same structure as the generic SAE-defined codes. Using generic OBD scan tool software, when we navigate to mode 3, 7 or 10, we are presented with a list of diagnostic trouble codes, including a description of each code. The fault codes may be either pending or confirmed, depending on the chosen mode. If we look more closely at the structure of the fault code, it includes a prefix: B for body system fault codes, C for chassis system fault codes, P for powertrain system fault codes, and U for network communication fault codes. For generic SAE fault codes, the next character is either 0 or 2. These codes are identified in the relevant SAE standards. Manufacturers can stipulate their own specific fault codes using a 1 or 4 as the second character. Other numbers or letters may be substituted, as determined by the manufacturer. In all vehicles, the SAE fault codes must be displayed under the generic OBD program in the scan tool being used. The third character in the OBD fault code is used to identify subsystems specific to the vehicle application. Looking at the fault code P0100, the 1 refers to the air metering and fuel subsystem. Another may be P0C00, where C relates to hybrid propulsion subsystem faults. The final 2 digits of the fault code are specific numbers designated to the actual fault identified. So, if we see a fault code P0301, we can interpret this as a generic SAE powertrain fault, localised to a misfire in cylinder 1. A key element which can be of great assistance during diagnosis is the freeze-frame data record. Under the standards, it is a requirement that whenever a fault code, either pending or confirmed, is recorded, a snapshot of the engine parameters is taken and stored in the ECM memory. This is provided that the trigger fault code is a higher priority than any existing snapshot recorded. The freeze-frame data record is then able to be later retrieved and displayed on a quality scan tool via generic OBD Mode 2. Under OBD2, this data record may be overwritten if a higher priority code is reported. However, some OEMs allow for multiple freeze-frame data records to be stored, which is permitted under the standards. This data is often extremely useful in the diagnostic process to determine what actually triggered a particular fault code. Remember, when clearing fault codes via generic OBD Mode 4, the freeze-frame data record will also be cleared, with potentially valuable data lost. As part of the OBD2 standards, OEMs must design their engine management systems to perform defined checks, monitors and evaluations to determine the operation of various emission components and to ensure that the vehicle emissions remain within prescribed limits. The different checks and evaluations carried out are referred to as monitors. These have a specific criteria which must be met before they run. Should a monitor fail, then a fault code, pending or confirmed, may be logged. Depending on the severity of the fault and how likely it is to cause component damage or cause the emissions to increase beyond their limits. The status of each monitor can be seen under generic OBD via Mode 1 and 6. Whenever a fault is rectified, it may be necessary for this monitor to run again to ensure the actual fault has been successfully repaired. Some monitors are run continuously, whereas others are only run at specific times, or when certain conditions are met. These conditions are referred to as trip criteria and will vary depending on the component or system being monitored. A combination of the system monitors may be run concurrently or in succession as part of an overall process referred to as a vehicle drive cycle. A drive cycle is often specified in OEM service information and can often be quite extensive. Until the complete cycle or monitor has run, the success of the repair cannot be completely verified. In practicality, however, this is often very difficult to achieve, given the very specific requirements of these drive cycles. The only obvious difference from a driver's perspective when operating a vehicle manufactured to OBD2 standards is the presence of an orange warning light, referred to as a malfunction indicator lamp or MIL. The OBD2 standards determine when this lamp must illuminate and how it illuminates. With the ignition switch turned on, the MIL will illuminate for a short period, which is effectively a bulb check to confirm it is operational. The MIL will also illuminate if emissions have exceeded prescribed limits, or if there is a misfire detected. This will change depending upon the severity of the fault, and if it has been detected in more than one trip. In severe cases, where catalytic converter damage is likely to occur, the MIL will flash, alerting the driver. For all vehicles conforming to OBD2 standards, the trigger activation for a fault code, or MIL illumination, will typically be 1.5 times the standard the vehicle was manufactured to comply with, whereas under EOBD, the trigger activation is based on exceeding specific limits. With both OBD2 and EOBD, these emission levels are modelled or calculated based on the engine operating conditions and the actual readings from various vehicle sensors, including the oxygen sensor. The OBD2 standard further extends into the naming convention given to components and how they are referred to in service information, as well as the data displayed on a scan tool. This ensures a level of consistency between manufacturers when referencing components and systems. Having a detailed understanding of OBD2 and what it can provide is a critical aspect of successful diagnosis on any modern vehicle. Without it, you may be missing out on critical information